I welcome you to this lesson. I'm teacher Katimbo Richard, teaching mathematics. Primary 7. Today we are looking at application of circumference in our daily lives, that is at school or after school. Let's see how applicable circumference will be or is wherever you are on this planet Earth. And now, when you watch this lesson, P.7 member, as a candidate, you will have an advantage of answering all the activities from page 28 all the way 29 of our book. And not only will you answer that, but also do apply circumference in your life, wherever you are now. Please, let's see how we can apply this, say, circumference in life, and we say circumference is all distance around any round object, around any circular object. Now let's see how it can be applied. And this is the first example, and now it reads: how many revolutions can a wheel of a car 35 centimeters in diameter make to cover a distance of 35 kilometers? The question is, how many revolutions can a wheel of a car 35 centimeters in diameter make to cover a distance of 55 kilometers? So whenever you bought any car, any vehicle, you are ably in motion or in movement because of circumference. That's why, anyway, all those wheels of the car are circular. If they were not to be circular, just imagine how you'd move. That's why they are circular for easy rotation. And when they rotate, when they revolve, when they turn, please, they make circumferences because they make journeys around them. And being that they are circular, they apply circumference. So that application of circumference makes you move from one place to another in your vehicle. So therefore, we are going to see how many times going to rotate. To revolve is to rotate. And the word revolution comes from the verb to revolve. So which means to rotate. So, like the abstract noun from rotate is rotation. So, the abstract noun from the verb to rotate, to revolve is a revolution. So, how many revolutions, how many rotations, how many times which turn that will turn to cover a journey of 55 kilometers, given that it is 35 centimeters in diameter? They are saying take pi as 10⁻⁷. Now, we must know this formula that number of revolutions is equal to distance divided by circumference. Number of revolutions equals distance divided by circumference, which distance we have as 55 kilometers. Now, what have circumference? You say, but circumference equals pi d. Remember, d means diameter. And now of the diameter, we use pi d. If it were to be radius, we will use 2 pi r or pi to r. But here, we use pi d. Why? We have diameter. Now we go circumference is called pi times d, which pi is written here as 7 times the diameter of 35 centimeters. Here, we cancel, we divide by 7 and get 1. 35 divided by 7 get 5. We make 22 times 5. You multiply properly, where 5 times 2 is 10, right? 0, you put 1, and then 5 times another 2 is 10 plus 1, you get 11. So circumference is equal to 110 centimeters. Now that the circumference is 110, you have it here. Remember, we are finding number of revolutions, which is formed by division of distance and circumference. Circumference is here as 110 centimeters. Only that we have different units. Then we cannot divide unless we have the same units. We cannot divide kilometers directly by centimeters. So the two are here, distance, but in kilometers, and circumference in centimeters. So for us to be able to divide, we must harmonize the units. We must have these units harmonized or agree, make them agree. So now I've got converting kilometers to centimeters. You write King Henry's daughter Mary drank cold milk. King Henry's daughter Mary drank cold milk. Let's go with that. King Henry's daughter Mary drank cold milk. Again, King Henry's daughter Mary drank cold milk. Actual meaning kilometers, hectometers, decameters. This is meters, decimeters, centimeters, and millimeters. So our concern is between kilometers and centimeters. This K makes a kilometer, write a 1, then write 0 up to C, where centimeters are. 0, 0, 0, 0, 0. How many zeros are they? 1, 2, 3, 4, 5. When 5 zeros are put onto 1, we've got a figure which is 100,000. So therefore, 1 kilometer is equivalent to 100,000 centimeters. It's the one you state here, having developed it in that way the examination. So then what about 55 kilometers? That's 55 times the same fact, 100,000. So we have 15 times 1 is 55. Say 55 times 1 is 55. Then bring down all the 5 zeros. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have 55 kilometer journey equivalent to 5,500,000 centimeter journey. And now, since the circumference and the distance are now in agreement in terms of units, centimeter, then divide centimeters and divide. So you get a number of revolutions now. That is 5,500,000 divided by 10. 1 revolutions, leave the centimeters alone. So we go by 10 by 10, 11 by 11 ones, 55 by 11 get 5, and then you remain with 4 zeros, up. So write those 4 zeros there. Therefore, the answer is 50,000 revolutions. 50,000 revolutions. 50,000 revolutions. So that is how many times this car tire will rotate. If it is 35 centimeter in diameter, 35 centimeters in diameter, to cover a distance of 55 kilometers. All in all, we must know that number of revolutions equals distance divided by circumference, which must be in same units before you actually divide. Like I've done, like must do, which when done, you never fail. Then as we look at example number 2, a wire of length 1,320 meters was wound around a cylindrical tin 600 tons. So 600 tons. Then a question, find the diameter of wire. You have seen people having tins or having a wire wound around something like a cylinder. We're assuming this is a tin and you see it's cylindrical. So some winds, to wind is like rotating around something. So you have a wire rotated around a cylindrical tin. How many times? 600 tons. Then find the diameter of the wire. Sorry, find the diameter of the tin. Now you must know all tins that are cylindrical are round. That's why they can rotate on ground. They can easily rotate on ground because they are circular. If they are circular, then when they rotate, they make circumferences like the car wheel I've talked about. So, therefore, 1 ton it makes, it will have applied circumference. Or 1 ton, once wound, to wind. Then the past simple or perfect is wound. Wound. It's like a wound, the spelling is the same, but the reading differs. Like say fold, find, fold. Then wind, wound. So to wind. So 1 time you wind is the same as circumference. 1 time wound means circumference. So therefore, when you find 1 ton, then you have found circumference. That's why you say 1 ton wound represents circumference. Now I'm going to convert the meters to centimeters. Why? The one in diameter in centimeters. So we go 1 meter is equal to 100 centimeters. Now the whole wire is 1,320 meters, which is equal to 1,320 times 100 centimeters. Then you multiply this by that by 1. So 1,320 by 1 gets 1,320. Then bring the 2 zeros back here and get this whole wire. The whole wire is 132,000 centimeters. And now it was wound around how many tons? 600 tons. So all 600 tons took the wire of 132,000 centimeters. What about 1 ton? We say we shall call it circumference. So 1 ton will get 132,000 divided by 600 and start your cancellation by 10 by 10 by 10 by 10. 6 by 6 once, and then 13 by 6 you get 2, remainder 1. 12 by 6 you get 2, and 0 by 2. By 6 please you get 0. And now when you divide successfully, you get 220 centimeters. So 1 ton takes a wire of 220 centimeters. So our circumference is 220 centimeters. Now find the diameter of the tin whose circumference is 220 centimeters. So what the diameter? We say pi d equals circumference. Pi times d equals 220 centimeters. Take pi as 20/7, that's 20/7 times d, which diameter equals 220 centimeter circumference. And now we multiply. So we've got 22 out of 7 times d, which is 22d out of 7. 22d out of 7 equals 220. We've got this as the party. This is a sine, this is a party. So I've got 2 parties whose LCM is 7. So evenly multiply either side by 7. We say 7 times 22d out of 7 equals 7 times 220 centimeters. We say by 7 once by 7 once, remaining 22d, which is equal to 7 times 220 centimeters. You are advised not to cancel this because we are still dividing, or we're still in the process. So go 22 divided by 22 equals 7 times 220 centimeters divided by 22. By 22 once by 22d, which is diameter. 22 divided by 22 once. Don't use 22 is easy. You get once and that's 0. So I've got 7 times 10 answer centimeters, where diameter is 70 centimeters. So our diameter is 70 centimeters, and no one will then fail in case they follow that kind of procedure. So ensure you follow that, and never will you fail anything connected to that. Now we can move to example number 3. It reads, find the number of concrete tons that can be made by a bicycle tire of diameter 70 centimeters to cover a distance of 88 kilometers. That question is directly related to number 1, given diameter and the distance. So the diameter is 70 centimeters and the distance in kilometers. So the tons are the same as revolutions, are the same as rotations. So the formula is the same. You say number of tons equals distance divided by circumference. Like we said, number of revolutions equals distance divided by circumference. Like we say, number of tons equals distance divided by circumference. So find circumference. You say by circumference called pi d. Circumference called pi times diameter. Circumference equals 20 out of 7 times 70 centimeters. We cancel by 7 once, and by 7 get 10. 22 times 10 get 220 centimeters circumference. The distance around this bicycle tire is that 220 centimeters. Now we have the distance in kilometers and circumference in centimeters. I say we first harmonize, or first make them agree. So we convert the kilometers to centimeters. As we stated before in number 1, 1 kilometer is equal to 100,000 centimeters. What about 88 kilometers? That's 88 times 100,000 centimeters. 88 times 1 is 88, and the 5 zeros, 1, 2, 3, 4, 5. Ensure there are 5 zeros then the whole journey is of 8,800,000 centimeters. So now, find the number of turns. You get that 8,800,000 divided by 220. Now that both are in agreement. So you cancel off 1 0 because common. This 0 and this 0. That's by 10 by 10. Then divide by 22. 20 divided by 22 once. 88 divided by 22 is a 4. 0 by 22 0. By 22 0. By 22 0. By 22 0. So thereby getting 40,000 complete turns. Those are the complete turns that this car tire, diameter 70 centimeters, will make to cover the said journey of 88 kilometers. So that is how we apply circumference in our comfortable vehicles. So then we go to example number 4, which is the last for this particular lesson. So find the length. Find the length of a wire that was wound around a slim nicotine 2,000 times if that tin was 28 meters in diameter. So find the length of the wire that was wound around that slim nicotine. This nicotine, as I said before, being circular, when you wind once, you have made circumference, and so doing, you use circumference to wind that wire around any nicotine. So therefore, we say one time wound represents circumference. So you must have a word that's a clue to application of circumference. So when you wind once, you have applied circumference. That's why you introduce it in. So you say one time wound represents circumference. Now let me find the circumference. Circumference is called pi b. Circumference is called pi times d. Circumference is called 20/7 times the diameter of 28 meters. I will cancel by 7 and get 1. 28 by 7 to get 4. Where 22 times 4, you get an 88 meter circumference. So every time one winds that wire around a nicotine, it takes an 88 meter wire. But now, how many times was it wound? It was wound around 2,000 times, meaning I'm going to multiply by 88 to get the length of the wire. You say one time wound takes an 88 meter wire, and about 2,000 times. That's 2,000 times 88 meter wire. So we multiply 88 by 2. 2 times 8 is 16, right? 6 to group 1. And then go 2 times 8 again 16 plus 1 is 17. You go 176 there, and then bring back the 3 zeros here. So therefore, the length of the wire that was wound around the nicotine's diameter is 28 meters, 2,000 times was 176,000 meters long. That's how we answer that question. In case you are asked such a question, get the circumference, then multiply by the number of times that wire has been wound around that same nicotine. And that's how we apply circumference in life, and the examples to come if we had more time. But now we will allow those ones. Please, they are enough for you to answer the activities from page 28 or 29 of our workbook, term 3. I am teacher Katimbo Richard, teaching the subject mathematics, the easy subject if practiced. It's very easy, it's the easiest subject if one practices, and if one didn't practice, then it becomes the other way around. So for more information about this or mathematics in general, that's in primary, please do reach me on these two numbers, 0776 251655, or use the Airtel line 07572 33066. Otherwise, it's the end of the lesson. Please stay safe I love you.